So my name is Chris Bowyer. Thank you everybody for coming. I'm Director of Building Operations here at the Alliance. I think I've met everyone in the room and know a good number of you personally and been on video calls or in-person meetings before the pandemic. So thank you for coming back. Let me get my slides going right. There we go. So as mentioned, we're going to talk about some of the work that we've done with our Living Laboratory program over the last year and a half, realistically. Some of these conversations began prior to the pandemic with Tyler and the Fermata team. We've worked with Kytera over the last year. IWBI's in the room. We have Branch Pattern coming somewhere. I thought Danny was going to be here. Parking, Switch Automation's here, so thank you. And a number of people on the phone, Jeff with Gensler and a number of other folks. So thanks everybody for coming. For those that haven't been to the Alliance Center, I wanted to give you a brief summary of what we do here. So the Alliance Center, it's a 40,000 square foot building. We have our own co-working space, not vastly dissimilar from the WeWork model. Open office areas, private desks, hot desking where someone can come in and just pop in when they would like. We also have the event space that we're sitting in today. In addition to that, we have 30 plus or minus tenant organizations. Those comprise about 200 desks here in the building that people can come in as they choose. The one interesting piece of that is they are all sustainability focused. That is a requirement to be in the building or be a part of our member community, is to be sustainability focused, whether that's traditional environmentalism, whether that is green finance, whether that's social justice. All of those are encouraged, but sustainability is a big piece of it. But what I do want to say is what we try to do is we try to demonstrate sustainability in a real world environment. That's what our goal is. That's how we try to convene our members, our tenants, and our work is really mobilizing change agents and making sustainability a reality. Here's some more pretty pictures of the building for those that have not been here before. I know we have a number of people from out of town, so not only is it relatively pretty during the day, but at night as well. So, Living Laboratory. This is what has brought us all together. Living Laboratory was a brainchild of myself and my direct supervisor, Jason Page. And the goal of Living Laboratory is to pilot sustainability solutions in a real building. And to kind of take the jargon out of that, what we try to do is develop a CapEx type project, some sort of project that makes sense for us to do in the building, and then add on a research component. We don't want to necessarily just save energy and that energy just be on our bottom line. That's not why we are here to exist. That's not what we try to do. Whether it's energy consumption, air quality improvements, doing anything in the building, we want to make sure that there is a research component or some sort of effort that allows it to be more market adopted, so that other people can learn from it, other people can do it. So that's why Living Lab exists. We do that in 3 areas. Operations, LEED Platinum building. It's been part of our work since 2004. Miss Patty and Miss Danny that are here in the room, they helped us out whenever they were with USGBC. They're still helping us out here in the building and as partners of ours, but it's been a piece of our work for a very long time. We try to work on air quality. We have Mike with Kytera here who's helping us out. He will share more about our air quality efforts. Waste reduction. I just did a presentation today about our hard to recycle station and our waste diversion efforts. Water, and then energy consumption. We also work with people. So we don't want to just look at the systems in the building. The systems in the building definitely operate at a high efficiency, something that we've done well with. That being said, the people that are in the building are that much more important. We want to be able to advance their productivity and make them work better whenever they're here with us, whether they're virtual today or whether they are actually here today. We want their productivity to be as high as possible, and we try to do as much as we can. We just earned the WELL Health Safety Rating. Thank you, ladies with IWBI. There's a lot that we're doing. We're exploring WELL version 2. We're exploring FitWell. We're exploring others to see what makes sense for us in the future for people. We also work with technology. We have a number of folks here that will talk about our Fermata project, a bidirectional electric vehicle charger. What does a battery in a vehicle do for a building to be able to use that battery for resiliency, for demand savings, et cetera, et cetera. So excited about that. We also talk about indoor air quality, and we also have a direct current microgrid. So many of you are probably already familiar with that. If you're not, we have solar on our roof, batteries in our basement, a 100% direct current grid that feeds one suite in the building. There's a long story behind the operability of it right now, and I'm happy to go into those details later on, but I want to focus on this evening. All of our partners. Many of you are in the room, either virtually or in person. We thank you. This event and the events of this entire week wouldn't be possible with all these groups. So thank you greatly for your support, either financially or as a promotional sponsor. Thank you so much. So tonight we'll go through 3 projects. We'll go through our vehicle to building project. We'll talk about our air quality project, and we'll talk with about our work with the future of work and what our partner Gensler sees as that future. So without further ado, I'll turn it over to Tyler Svitak. He introduced us to the Fermata team, and then hear from John Wheeler on that team. So Tyler, if you want to come on up.
Thank you, Chris. And thanks to everyone that could join in person today, as well as everyone virtually. As Chris mentioned, my name is Tyler Svitak. I run the Colorado Smart Cities Alliance. We're a 501c3 nonprofit that gets to spend every day looking at how new technology solutions, like vehicle to grid, can be applied to complex problems here in the state. The thing about complex problems is that they're complex, and in order to solve them, you need a lot of different partners at the table. We specialize in having a network of those folks that want to do these things and try things for the first time. And in this case, the Alliance Center stepped up with this vehicle to grid technology deployment that you'll hear more about from John here in a second. I think we all recognize, since we work in the sustainability space, the problems that are ahead of us. They're significant. Climate change, air quality, other problems we work on, like affordable housing and energy costs. These are big, hairy, complex issues. And fortunately, there's a lot of new technologies out there that can give us new tools in order to approach those problems in different ways. Vehicle to grid is something that I've been learning about and studying since I started in the industry back in 2011. But in order to actually do that, you need a lot of players to come to the table. You need a lot of technology that is enabled that didn't become available until what Fermata ended up offering here very recently to the market. And you need willing hosts, you need potentially willing utilities, you need a willing automaker, and you need all of them to come together and actually do it, right? Implementation is very different than planning. And this project that you're going to hear about is an example of how all of those folks came together in order to prove something new for the first time here in our state and one of the first times here in the country. And we had a great time having a very small part of this project is bringing Fermata Energy, one of our members, in contact with the Alliance Center and with the city of Boulder. So there are actually 2 deployments of this that John will talk about here in a second. And we're trying to take this project and apply a research angle as well to see how this could maximize the grid and reduce costs for lots of people out there. So without any further ado, I'm going to introduce John Wheeler. He is the co-founder of Fermata Energy and the CFO.
All right. Hello. We are Fermata Energy, and we turn EVs into energy storage when they're parked. And here's why. we need to decarbonize the electrical grid, and we need to decarbonize transportation. And we're too late. So while we're waiting for all that to happen, we also need to provide resilience to communities facing challenges and impacts from climate change right now, today. And we need to do all this equitably so that no one's left behind. And most importantly, we need to do it right now. We can't wait 10 years and $100 million in R&D. We need a viable solution with technology that can be scaled right now. So here's the plan. We need a lot more renewable energy on the grid. And to do that, we need to be able to store wind and solar energy when it's needed. Basically, when we come home from work, we start making dinner and the sun is going down. And the problem is that energy storage right now is still very expensive. But turns out there's a better solution, actually, parked right outside the buildings and homes, right where power is needed. If we could turn parked EVs into energy storage, basically free or found energy storage, then that could provide a solution to scaling renewable energy right now very quickly. And what's more, if those EVs could be paid for providing that service, then their cost comes down because EVs are also really expensive. Then EV adoption increases for everybody. And there's more storage on the road then, and more renewable energy. And this is exactly what we're doing right now with the Alliance Center and Colorado Car Share and their buddies up the road in Boulder. Fermata Energy is integrating software, hardware options, and most importantly, knowledge to not only charge EVs, but to let the EVs power buildings in the grid. Okay. There is no resource more valuable today and so underutilized as an EV. Absolutely. Like most cars, EVs are parked 95% of the time, often full of energy. We charge them at night. They're full of energy in the morning. We drive a couple of kilowatt hours to work. We can plug them in there. They sit around full of energy, literally doing nothing all day, 95% of the time. Now hold that thought. The grid stationary storage industry probably sold well over $1 billion of stationary assets in the US alone last year during COVID. You cannot buy a home energy storage system now. There's a shortage, can't buy them. But an EV has anywhere from 4 to 8 residential energy storage systems on board the vehicle in that battery. That's like $40,000 to $60,000 of cash sitting on the hood. And OEMs are finally realizing this with announcements from Ford with their new F-150 Lightning and VW. Those guys are bringing models with this capability to the market as soon as next year. But it turns out that we actually don't need to wait because there's already significant capacity on the grid right now with the Nissan Leaf, which has been bidirectional and V2X capable for a while now. So Nissan sells about 15,000 Leafs a year, which is okay. It's pretty good for an EV, but they sell 200,000 Sentras, okay? But yet, the modest sales of that one single vehicle in the last couple of years, 15,000 units a year, that one model vehicle represents more energy storage capacity right now than the entire stationary storage industry combined. That's all deployments deployed in the last 20 years, utility scale, home, commercial combined, one modestly selling car. Now imagine if instead of one vehicle, there were 2 or 3 models available, like next year. Then you get energy storage capacity, orders of magnitude greater than everything that exists right now, being deployed every year. So that's a 10x, that's a 20x, that's a 100x, that's a moonshot. That's a moonshot result using technology that is scaling right now today. And automakers are going to be deploying this technology whether we utilize it or not. So we are utilizing it, actually. We're doing it right here, right out in the parking lot. This is one of our first sites, actually, in Danville, Virginia, where electricity prices are actually pretty low. It's a rural area. They're critical partners for it. But yet, we're making around $200 a month just by doing one application. Demand charge management, which Chris so eloquently described in his PBS special a couple months ago. I highly recommend it. And that's great, $200 a month. That is almost enough to cover the lease of a Nissan Leaf. And here's up the road in Boulder. Those are real results. COVID prevented us from deploying last year, as it prevented many things, but we finally were able to get iron in the ground January and started producing almost $300 a month with a parked car. And that is more than enough to cover the lease of a Leaf. And in markets like in the Northeast, in California, it's $400 a month, $500 a month. And here we go. Here's the Alliance Center. We've been running for a full month now, and we made almost $300 a month with a parked car that's being driven. It's actually being driven right now. I hope the building's not peaking. It's hot out. Now, imagine if you're a family and you cannot afford personal transportation. And because of COVID, and God forbid, Delta, you can't take public transportation. And throw into that, your power is being cut off because of wildfires. So this technology now can provide access to clean mobility, a cleaner grid, and it can power your home and keep the lights on. We're working on that next application this year. So we're deploying across the country. We started deploying late last year with our betas with utility partners, as well as fleet partners like the Alliance Center in Boulder. And it's been great. We still have a lot of work to do. And I want to echo everything that Tyler and Chris said. This technology, in order for it to work and grow, it needs to exist in the real world. There have been many vehicle-to-grid science projects that, were on microgrids that don't really produce any commercial result. None of these, almost none of them, are pure science projects. These are mostly making money in a commercial context because it's essential. And to do that, you have to have partners. You have to have partners using the technology in the real world, producing real value with real results, making real mistakes that you can learn from. That's probably the most important thing. And we look forward to continuing on that journey with the Alliance Center and working together to make the product better and scale. Innovative technology is completely useless if there aren't vanguard partners like the Alliance Center and Colorado Car Share to actually give it a shot and to make it better. And so I really want to thank everyone here, everyone on the Colorado Car Share team, and the Alliance Center, and Tyler's team. This has been great, and I really look forward to what's next.
Danny, have we gotten any questions online in the chat? Nothing online? Is anybody on there do have a question before we go to the next presentation? Yes, from the room. In case people can't hear, just repeat the question.
So are you talking about, did you say just in homes or everywhere? Anywhere. So here's what you need. To do vehicle to grid, you need three things, basically. One, you need a car that is bidirectionally enabled. And right now, that's basically the Nissan Leaf. That thing has been bidirectional since Fukushima, actually, for resilience reasons. But there's more models coming as soon as next year. The Mitsubishi Outlander is also bidirectional, but it has a smaller battery. So you need a bidirectionally enabled car. The second thing you need is a charger that's bidirectional. Right now, the easiest way to do that is to have an off-board DC bidirectional charger for various reasons. We have our own charger right now. It is the only one that you can deploy on the grid commercially with a light-duty vehicle, but there's more coming. And we want to be working with lots of charger manufacturers, and we are right now. Our next charger is actually being produced by a partner of ours. But the final thing you need is software to make it all run. You need software to not only let that asset, let that vehicle participate in various grid activities, whether it's wholesale arbitrage or demand response. We're doing demand response in the Northeast right now, which is great. Or to do demand charge management with a building, or to run backup power to your home. There's probably 10 or 15 different things a battery can do at any given moment. You need software to enable all that. That's really the technology focus of Fermata. But there's actually a fourth thing you need, which is arguably the most important, which is knowledge, which is the use case. How do you actually use this technology? People have been, discharging EVs for a long time. But the challenge has been for this technology is how are people actually going to use it? What's the use case? It's a very complicated technology. It's got lots of promise, but there has to be a way to roll this out so that people can understand it and actually make it a reality. And that's really where the focus of the work of Fermata is, and the focus on partners.
You asked whether or not we could deploy this at the home. Could you clarify what we're doing in the commercial space and what are?
Yeah. So
Repeat that a little bit, John.
right. So right now we are introducing this technology with fleets in the commercial. So we have a commercial system right now, and there's various reasons for that. One of them is because fleets in a commercial context, it simplifies the use case. That's one of the things we try to do with this initial market is let's just simplify this as much as possible. We generally know what fleets are going to do. With a car share system, we actually can control the car and actually make a reservation to do some grid activity, and then someone else can reserve it to go drive around. It's a very controlled, easy, well, it's not easy, but it's a good use case. Getting to your home is a little bit more complicated because you can drive the car and might want to do anything you want at any time. So there needs to be different levels of software that enable you to understand really how much your car is worth and when, so you can make an informed decision when you want to go get groceries, or let it sit in your parking lot and make $50 an hour. To do that, you will need, again, probably a bidirectional off-board DC charger, which there is a premium for that, but that is quickly overcome by the amount of revenue that even at your home, a charger can create. So if you're trying to future-proof your home right now, I'd say you want to put in a large breaker. You want to make sure you have enough access to power, room on your breaker switch to put in depending on how big your home is, a 6 kilowatt, 15 kilowatt. There's a range of probably 10 to 15 kilowatt units that I know of that will be coming to the market probably over the next year. Most of them will be working with Leafs, but the Ford product will be working with a big old pickup truck. But you want to make sure you have access to power and room on your circuit board, on your circuit breakers to handle that.
I think there may be a question in the chat, John.
Yeah.
You can read that one out so the people in the audience can hear. And then
Okay. Let's see. Making $200 to $500 per month sounds good. Is it getting in the ballpark of reasonable payback period for the upfront costs? Or do you anticipate that is foreseeable? Yes. So with the next charger we are making, that our partner is producing, it's going to be at a price point where should pay back, depending on how you finance it, very quickly. We're looking at like a 2 to 3 year payback in the commercial space. Now, that's without any financing. If you finance it, there's use cases where you can get a free product right away, basically, because you can make more money than it costs to finance it. The big thing here is we are taking what is traditionally a cost center. Okay, so a charging infrastructure is a big cost center. Even if you get grants, thank you, RAC, for the grant, to pay for most of it, it's still a cost center. We're taking that cost center and turning it into a profit center. The charger, after a couple of years, will pay for itself. Then it has an ROI, and then you're paying down the cost of the car. And there's some applications, some markets where you can get a free charger, and at the end of 10 years, which is about the life of the charger, you get a free car. I'm not kidding. You throw in subsidies and grants on top of that, you get something that's disruptive. And that's the whole mission here. We need a disruptive moonshot to move the needle on climate change.
Thank you, John. Thank you, John, and the Fermata team. We're going to keep moving on to the next presentation. We will have some time afterwards to answer more questions for those that are at home. Please send them in. We will make sure that any question that's asked of a group, we can follow up and follow up with you in the best possible way. So leave your contact information if you'd like. The one piece I did want to make sure that we identified with this Fermata project, at the Alliance Center, it's not just about the cost savings for us. We want to make sure that we're providing the data to others to replicate this, to show how important this is, and to show what the advancement opportunities are for vehicle to grid, vehicle to building, or vehicle to home. So we're working with Tyler and his team, the Fermata team, and researchers that are local to try to find either the social, the financial, or the ability to advance this on a much broader basis. So make sure that that's 100% understood and that we're not just doing this for the cost savings. It's great. We love to be able to save greenhouse gas emissions, but we want to make this much more widely adopted than just the Alliance Center or Boulder or Danville or any other site. So I will hand it over to Danny to introduce the next group. Danny is a former tenant. Maybe in the future, Branch Pattern can be a new tenant. But Danny will introduce the next group and kind of go from there.
Hi, everyone. My name is Danny Diono. I work at Branch Pattern. It's nice to see so many familiar faces. What? Scooch over? Oh.
It's on the screen in front of you. So you can see where you're at.
Hello. Okay. Do I have to repeat myself or do people hear me?
People probably.
Okay, great. All right. So I'm going to introduce the indoor air quality monitoring and research project we've been working on. My colleague, Stuart Shell, who's virtually attending, he lives in Omaha, is going to walk you through what he's been doing, but I'm going to introduce Branch Pattern really quickly. Okay, so Branch Pattern is a building consultancy made up of building scientists and engineers. And we really draw our name from the nature that inspires us. One of my favorite examples is how we currently design our HVAC systems, which this building has them exposed, you can see. So the way a plant carries nutrients up to its leaves is through a curved system, and how it grows roots is through a curved system that's formulaic. How we design HVAC systems are at 90-degree angles. So it's actually not the most efficient way to design our buildings. And I like to use that as an example of ways we can draw inspiration from nature to make our lives more efficient and better. Stuart and I are both a part of the building science division. So the building science is has these 4 parts to it: quality managing consulting, commissioning and testing, research and development, and green building consulting. And when Chris reached out to me about this project, he mentioned the Alliance Center itself is really near and dear to my heart because I used to be a tenant here. And I'm so excited by all the projects and passions that Chris has for green building. But we as a company want to progress our research and development group and have more case studies similar to what Chris was saying to really expand and scale some of these efforts. And so we saw this as an opportunity to show other clients what indoor air quality measuring can do and what this data can do for the building tenants. All right, Stuart, take it away. Can he?
So we're gonna bring him up on video.
Okay.
Stuart, give us 1 minute. We're gonna bring you up on video so that people here can see your face.
I love hybrid, y'all. All right, Stuart, whenever you are ready.
Oh, great. Well, thanks so much. I appreciate you guys making the space for this conversation, putting in the effort, and, you know, not just physically, but rhetorically also. This is an inspiring opportunity that you've offered, and I want to talk a little bit generally about indoor air quality also in this context, and explain why I put indoor sort of in quotes here.
Yeah, you ready?
Again.
So the first, thanks. The first point, oh, did I zoom in too? To make is that we are generally getting better with air quality. So that's some good news that I'm happy to bring you. This is really a global trend, but as well as in the United States. Air quality is improving because we're cleaning up our technology in general. And there's a greater appreciation for the risk today than there has been in the past. I think our regulatory environment can continue to improve with your continued efforts as citizens. So death rates have also come down. This is showing them globally because of improvements to indoor air quality primarily. And that's because for so much of the world, we've been able to move away from solid fuels for cooking. Cooking is still probably the greatest hazard, even if you have a clean fuel like natural gas. That said, this is good news. This is reassuring that our lungs are healthier today than the generation before us, and that should not be lost on us. You know, that sense of progress. That said, air pollution is still one of the underlying causes of our losses of years of life. And so you see ranking in the top 10, there should be a continued focus on what are these causes of pollution and how can we safeguard ourselves from them, both indoor and outdoor. So, just confirming, you get, okay, yes. So from a technical perspective, we understand really how to provide an indoor environment that has a clean, is respiratory good situation for us. We do that by first checking that the outdoor air is safe to bring in, if it's not, cleaning it, and then identifying sources inside. Often, as in the case with cooking, we're our own worst enemy when it comes to pollution in the environment that has negative health impacts. But the point of this slide and sharing, it's really some researchers that remind us there's only one air. There's not an indoor and outdoor air. Those are sort of ways of shorthand for us talking about which strategies we might use to address the pollution problem. But the experience that you have indoors is linked directly to the ambient air quality outdoors. And so it's one problem we need to solve together. We shouldn't imagine that our buildings can protect us from poor ambient air. That said, we're actually not that good at doing this. This is a recommendation for a health-based approach to ventilation in buildings, one that we don't follow. We tend to just jump right to providing a certain amount of outdoor air and skip some of the steps that are shown in this chart. All that said, it's not that important how we practice technically solving air problems, because they're not really that much of a concern for a lot of people. This isn't very high up on people's complaint list. I think that might be starting to change, and that perhaps the pandemic has been making us aware of the critical role that our design plays, and our human activity on the planet also, to be frank, in providing for resilience. So honestly, this is where I think we have the greatest hope, is that there's more awareness for the importance of a background healthy environment, so that when we have challenges to our immune system, we have the resources to overcome. So that was a lot of background. Just to provide some context for the research question that we saw an opportunity to ask, and I'm so thankful, Chris, to your team and the Alliance Center for inviting this research. And I think we wanted to really understand what would provide the greatest opportunity for market transformation. Where is there really a need for more knowledge around how our solutions fit with the problems in front of us? These certifications really can help raise awareness and hold up great performers. So we've designed a research project that actually aligns closely and can achieve the features or credits that are within the most popular third-party rating systems. So looking at the human centers, we thought would be the most relevant, again, because it's the behavioral change and awareness that's underlying action, which is, it's not lack of technical knowledge or awareness of the building physics related to air quality. That's not our problem. Our problem is we're not investing in technologies. So why not, right? And so we thought we'd ask two questions: is if we provide you information about the air quality, what's that do to your behavior as an occupant, as somebody in the building? Also, how does that make you feel about your risk? Does it have an impact? Do you even care if this information is available? Big thanks to Katera, who's going to be talking in a second about bringing us technical solutions that allow us to ask these questions in the first place, really to the marketplace in a way that they haven't been available in the past. So this is one of the sensors that's installed there at the Alliance Center. It provides a screen, and for the sort of null condition, the screen doesn't show anything. The sensor's still working. We're still monitoring the air just from a building management perspective to ensure the safety of the environment, really the underlying reason that there's this network of air quality sensors installed in the building. But then in the condition where we provide the intervention, the experimental intervention, that's where the monitors displays are turned on. We also provide, Katera has an online dashboard. So if you're working from home and you want to know what the air quality is in your workspace at the Alliance Center, you can log in and check. To make this very convenient, as part of this condition, we also are sharing in a weekly update delivered to your inbox of how the air quality has been for the last week. This again is provided kind of through this third-party dashboard of Katerra. So there's, I think, a great opportunity for confidence in the occupant of the veracity and quality of the data. You know, we mentioned some of those certifications. Reset is a standard bearer that certifies monitors, and so you know, the Katerra products fit within that third-party certification also. All to say that the actual intervention is this survey. We made it very short. There's 2 questions, and then a slider for how many days you came in. So even if you didn't come in, we're still interested in your responses. Like maybe you're not in the office, we'd still like to know what you think the level of risk is in the building. We're doing this in a repeated measures design to get enough statistical power. We think there's a 75% chance with this research design that we will find an effect. So that is you know, avoiding accepting the null hypothesis when we should reject it. We're halfway through. We actually just started our second round of the condition B with the providing the air quality information to occupants. And to wrap up, so we can get to questions, I think I've actually exceeded maybe my allotted time here, but we really think that this information can give us knowledge about how much occupants actually care about providing these sensors. And if it turns out they care a lot, then this is a no-brainer for organizations to replicate. We also think this can tell us something about the choice to come into work, and if there's a correlation to perceived risk of air quality. If because we're asking people how many days they were in the office for a 2-week period of that condition. Finally, we think that there may be differences between groups, so we collect demographic information from participants. Participation is anonymous, and we're protecting their responses, but we're still going to correlate their data across age groups and see if there's any generational differences there. So with that said, I think there's maybe a little bit of opportunity for questions about the research design before we maybe talk a little more about the technology behind the product. Are there any questions?
Stuart, I might have one in the room here.
On one of the charts, it showed that there was PM particulate matter. There was this huge spike in 2000, and then it went down. I just wondered what that was. Why was that spike so large during that period of time?
Yeah, Stuart, so the question was, there's apparently a PM spike in 2000. I don't know if it was 2.5 or 10 or something else. And wondering if you know what that spike may have been and what caused it.
Is that a room number?
It was on one of
2000?
your charts.
No, it was not. It was the decade.
Oh, the decade of
Yeah.
2000.
Yeah, the decade. It was on one of the.
I'm not sure. It can be that sometimes activity like a volcanic eruption can create particulate matter phenomena.
Yeah.
Oh, yeah. Honestly, I don't know why there was an increase in the ambient air of fine particulate. It could actually be measurement error, or it could be related to some more global event like fires, for example. But yeah, I'm sorry, I don't have a better answer for you.
Yeah. There was a comment in the room that it may be 9/11.
If it's global data set, this could be like, that was the peak of Asian development, like before they really started.
US.
Yeah.
Oh.
Yeah. All right. What's up? Yeah, so we're talking about whether this is global or US, and this is a US graphic. So in the global scale, there was a development in China, I believe it was, Mike, is that correct? That grew in that time period. So not certain when that was. With that, I'll probably turn it over with Mike at Kytera and kind of go through his side of things, and we'll leave more time at the end of his presentation to talk more.
All right. Hey, cool. Well, hey, thanks, Stuart. And yeah, thanks, Danny. So just start this off with a visual of what Stuart was just talking about. This is one of our air monitors. It's actually installed on the wall over there next to the coffee shop. There's been a request for more volume. Is this better? All right, cool. Yeah, wave again if I trail off. But yeah, this is what it looks like. As you can see, it kind of fits in with a lot of the other cool things that are on the walls around here. We tried to make it look high tech. So let me tell you a little bit about Kytera. A few weeks ago, I was a software engineer in Silicon Valley. I saw what Kytera was doing and the impact they were having, and I decided I needed to be a part of it. So now my job is to talk to people like you about your needs and make sure that we're building awesome things. And the general mission of Kytera is to take indoor environmental data and turn that into actionable information for you to make your building more efficient, make the occupants healthier, and ultimately make a real impact on the global CO2 problem. So these are a few of our products. The SenseEdge is the one you just saw. SenseEdge Mini is the same thing, but with no screen for when you have a large deployment, don't need screens everywhere. And then we provide software tools for aggregating all that, turning that into action items, making sense of it for you. And over the last 5 to 10 years, there was already a trend of people starting to care about indoor air quality. COVID really gave it a kick in the butt. These are the sorts of people who you might not expect, but actually are buying into indoor air quality because they see that it's profitable for them. So large corporations, governments, of course, research institutions, really, a diverse global conversation and investment that you might not have expected. And these are the sorts of buildings that have installed our products. So Empire State Building, large office buildings, a cruise ship, the Well Living Lab. So people who are really paying attention to air quality, a sports stadium, the Apple Store, and then of course a coffee shop or your home. These solutions really apply everywhere. So starting at sort of the human level, before I get into the big picture, these are the things that when you talk about indoor air quality, these are kind of the common parameters. So PM 2.5, if you were outside today and you smelled some smoke, that's PM 2.5. Smog, industrial emissions, traffic emissions, that stuff is very harmful, makes you dumb in a short run, takes years off your life in the long run. You don't want it in your air. VOCs are emitted traditionally from paint, plastics. These days, while we're trying to keep our spaces more clean in COVID times, a lot of cleaning products are emitting VOCs. So we need to keep an eye on that. CO2 is what we're all emitting right now. As it builds up in a room, which it won't here because we're have such a well ventilated room, a lot of them aren't. It'll start making you tired. It'll impact your ability measurably to make decisions, to be smart in a business context. Another thing about CO2 that has sort of come to the fore is that in COVID times, we noticed this is sort of a proxy measure for how much virus there might be in the air. As you emit CO2, as you exhale, if you're carrying virus, you're also exhaling virus. We can't measure virus particles in the air right now. So the next best thing we have is measuring how much CO2 is in there. Humidity, when your humidity is too low, you can't fight out viruses as well. So these are real pertinent, timely health considerations that, you know, if you have a space like this that's paying attention to your indoor air quality, it really stands to make a big impact on your life. Next to that list of things, you see the Sense Edge from the bottom, and those two at the top of the bottom, those two curvy rectangles with the donuts cut out of them, those are our air quality module, sensor modules. And a lot of, you know, we're really proud of this design because most solutions, when the module needs calibration or replacement, you need to replace the whole product, or you need to have someone come out, fly out to your location, spend hours on site. It gets costly, it's wasteful. Here, you can pop out that module. It looks like the little gray box you see in the front. It's a tiny little aluminum thing. You ship it back to us. There's very minimal material turnover. We send you a new one. Within 5 minutes, you have a recalibrated sensor. You also have the opportunity now to monitor new things. So an emerging technology we're seeing right now is people want cleaner air. And a thing that you see a lot is this technology called bipolar ionization. The idea there is that it's supposed to neutralize viral particles in the air, so there's a lot of uptake of this. A side effect of this technology is it emits ozone into the air. Ozone is a caustic chemical. It destroys your body as soon as you breathe it in. You really don't want it in your building. So you need, now we need solutions to monitor that. So within a few weeks, we'll be shipping a module that looks like this that you can just pop into your device, and now you can monitor ozone. And this is there's a Sense Edge. On the other wall, you can see the kiosk view that Stuart was talking about. It gives you more aggregate view of what's happening in your building. Also, it shows you what's happening outside, so you can be reassured, on these fire days that, okay, the air out there is awful, but look, my building is taking care of me. It's really nice inside. Okay, so collecting this data is one thing. Then what do you do with it? So, there's the psychological aspect, there's the health aspect. There's a real opportunity for creating more efficient buildings. And this is where it gets really interesting. So in order to do that, you need to be able to hook up these devices to building management systems. So we speak all the kind of building management languages. Yeah, those came out kind of funny on the slide. You don't really want to know about those terms anyway, but those are just different machine languages that this thing can speak to talk to your building management system to make real-time tweaks to airflow, air filtration, temperature, things that really impact the efficiency of your building. This was a pilot study we did with Microsoft. I'm gonna get my water real fast, sorry. We put air monitors outside, air monitors inside. And with that information, so if it's a smoky day, you need to turn on the air filter. Running the air filter is expensive. You're burning through filtration materials, you're using power to filter the air. If the air is nice outside, you don't want to be running all that. You get to save a lot of energy. If you have an air monitor inside, that tells you again, okay, the air in here is pretty good, we don't need to be doing filtration. So with this 3-part system, you can save a lot of money and have healthy air. But there's still a whole lot of work to be done along those lines. We're really just starting to scratch the surface of what can be done leveraging indoor air quality information to make healthier, more efficient buildings. And that's one of the things that's really cool about this living laboratory collaboration and Branch Pattern is, we're taking a real detailed look that'll then become things that we can share with other people and make a measurable impact on the global situation. And so what is the global situation? In not so many years, we'll have twice the amount of buildings that we have now. Development is not slowing down. And already buildings are using 40% they're producing 40% of world CO2 emissions. That's construction and operations of buildings. Operations of buildings is about 30% of global CO2 emissions. 40% of that is HVAC operation. So if we can take indoor air quality to make tweaks to how much we need, how much energy we need to be spending on HVAC, we can make a real powerful, tangible impact on this global situation. And that's kind of it. Yeah, I hope Stuart and I got you a little more excited about the potential for impact here, and yeah, look forward to conversations to brainstorm solutions. And with that, I'll take questions for Stuart or myself. And if there aren't any, that's great. All right, thanks.
Thank you, guys.
Yeah, thank you, Mike. Thank you, Stuart. Thank you, Danny. I think the kind of important things that we want to highlight for here at the Alliance Center is that installing a sensor in our building isn't where we're stopping with this. We have the research that we're already doing with Branch Pattern. We're looking at ways that we may be able to tie our sensors or maybe new sensors into our BMS system or building mechanical system to try to control that system, whether there's a need to reduce CO2 in a space, whether there's it's a fire day here in Denver, do we shut down the dampers that are pulling outdoor air into the building? We're trying to look at all those things and find ways where we can make energy efficient improvements and modifications in our buildings so that we are performing at our peak efficiency and doing the best that we possibly can for our occupants. So with that, I will kick it over to, we're going to kick it over to Jeffrey and Teen over at Gensler. They are virtual. So for those in the audience, you'll see them up on the screen here. And we will go from there. Jeff, give us 1 minute to pull you over to the screen and we'll tell you when we're ready.
Sounds good.
Yeah, I'll give you a remote control.
Okay.
All right, Jeff, you should be able to control your slides now.
I'm trying. Yeah, it doesn't seem to be working.
It says you're controlling the screen.
Are you clicked on the right part of your desktop there, Jeff?
Oh, there we go. That's the problem. All right. So a little bit about us. I'm with Gensler. We're an architecture firm and interior design firm, and I'm the sustainable director for our office in Denver. I'm also a senior project architect, and we deliver commercial projects across the Rocky Mountain region. I also want to introduce you to some other people on my sustainability team. Christine Nicholson is here with us tonight. She is our Flex One sustainable leader, and she focuses on interior design. And then Rebecca Wagner is our Flex Two sustainable leader, focusing on architectural design. And Gensler is a worldwide design firm transforming the built environment through the power of design. Gensler was founded in 1965 in San Francisco by Art Gensler with a focus on commercial interior architecture. The employee-owned company has grown its design focus to 28 practice areas and 49 offices across the world, covering brand design through city planning. The Denver office is Gensler's third oldest office, with 48 years serving the local community. Backing Teen and I, we have 101 professionals and leaders that we rely on to deliver this great work. Our designs across the world have saved 17 million tons of annual carbon emissions, but this is nowhere enough. So over the last year and a half, we have seen an acceleration of health and wellness concerns in the workplace. Today, we'll share some of these trends as we enter the post-COVID office, but our focus on health must include climate action. Planet wellness equals people wellness. And I think this ties really well into the previous presentation. Teen?
Yeah, absolutely. I totally agree, Jeff. I was thinking the same thing as everyone's been speaking, that there's no way to separate the value of both human health and environmental health and the role that buildings have in that. But what I'm going to speak to you for just a few minutes is that human connection, and our presentation we titled Reconnect, just with this idea that as we emerge from the changes that the pandemic brought to us, what's really going to drive us is that desire for human connection and reconnecting with each other. There is a relationship between the experiences and the places that we value, and this is more important than ever. The pandemic highlighted this importance because when things were quickly taken away and home became the only environment where you could work, live, and play, sometimes with your family and kids and dogs and cats all in the same space, it really, really highlighted some things that I think we've all taken for granted, with the sense of place and experience. And experience as a buzzword, I'll try not to say too many times in this presentation, but it's really what the connection all ties back to, the experiences that we desire to have and how architecture can facilitate them, which is really the goal of what architecture does. So in talking about kind of rediscovering this human experience and human-centric design, that's really the focus that Gensler takes when we're talking about trends and the research that we're doing about successful workplaces in the post-COVID environment. What's really interesting is that none of these, there are actually not new trends. There's not anything that we weren't seeing prior to COVID when it comes to the workplace that we're seeing emerging now. But through our research, we're just seeing an increased focus on the trends of experience, autonomy, and choice. Things that we all got to put into practice, whether we liked it or not, during the pandemic. And so just in talking about the opportunities we have here, the pandemic also highlighted, as others have mentioned, our need to prioritize health, equity, and sustainability. We saw firsthand how the natural world can bring the global economy to its knees. This time it was the pandemic. Next time it might be climate change or something else. But the idea that we need to be ready to respond and also start taking more preventative measures with anything that we have within our control has been highlighted by the pandemic. And so I'll talk just about a few of the insights that we're seeing that are defining the new workplace that come out of this focus on connectivity and experience. So the new workplace is kind of the idea that we have this opportunity as we're returning to the office to improve upon some of the things that a lot of us used to not like about the office and that we got to experience in a different way. So the role of the workplace and office building is evolving. It's not set in stone. A lot of our clients are asking what we're seeing right now, and it's an evolving situation. But what we see is that work and place have become uncoupled. They are not married. And our research has shown that the majority of employees want to come back to the office only 2 to 3 days a week. So the office needs to support this transformation and be the place that is best suited for people to be together and support the activities that actually need to happen when people come in and be together, all the while supporting the ability to seamlessly integrate technology. The physical and virtual experiences must be fully integrated. So culture, community, and collaboration at the core of it all. What is the fundamental role of the office? It's connection through building relationships, all those things that don't work well at home. You're not networking, you're not, getting a lot of really genuine mentorship, etc. It's the pre-pandemic trends, like I mentioned, that are accelerating, which are choice, autonomy, and a focus on health and well-being. So those have only fully been highlighted by the pandemic. And building owners are really focusing on healthier buildings. We've seen an uptick in clients pursuing Fitwel, etc., just like was mentioned previously, which is great to hear. And then finally, some other buzzwords, flexibility and adaptability are just absolutely critical for the hybrid workforce and the paramount consideration when thinking about changes you might make to the office. The new workforce will be hybrid. There will obviously be a range of policies at different companies and how they support this, but it's going to be hard to go back to a world that doesn't support a hybrid workforce. And so the majority of companies will need to figure out how to make this work for them. And that means office buildings will need to be smarter and our designs will need to be more responsive as the work patterns continue to evolve. Like I said, it's definitely not set in stone. And that's why it's been really exciting to continuously throughout the pandemic survey the Alliance Center, where we got to do our workplace index survey with you all. So we'll continue to keep an eye on how things are evolving. But this is what we're seeing as far as trends and how they're highlighting right now.
And to move to our first kind of climatic trend, I kind of want to reframe an old sustainable strategy. When I was in elementary school, the teacher presented the concept of reduce, reuse, and recycle to the class and stated, reduction is the best thing you can do for the environment as you're not using something. The second best thing you can do is find a new use for that object, and then finally recycle it. So as our drive towards energy efficiency has reduced operational carbon emissions, it has exposed the large amount of embodied carbon in buildings and materials. So the best thing we can do is adaptively reuse these spaces, places, and materials. The idea of adaptive reuse is scalable from the product, the interiors, the building, and the city. As our first climate trend, I want to kind of, sorry, excuse me. So this first example I have is at the interior scale. And we strategize with the Irvine company to design a flexible workplace. And this workplace could be adaptable through their whole building portfolio. The big idea here is that building less and using modular options of furniture to meet the space needs of the tenant, we can create a flexible work environment. So when tenants grow or shrink within the building, the furniture can move across the Irvine company's building portfolio to accommodate the changing space needs of their tenants. So we don't need to build new things or new spaces and use more resources. So the next example is at the building scale. This is a project in downtown Denver, and we call it the Link. And this is the revitalization of the old CenturyLink building, and the project was a underutilized and vacant office building. And by renovating it, we can reconnect the urban experience at the street and transform the building into a high-performing workplace. We took this opportunity to examine the embodied carbon impacts. The project saved 68% carbon emissions as compared to a newly constructed building of the same size. And this, if you look in the upper right-hand corner, that's kind of the two footprints. The left side is the new building and the carbon that would take to build that building. And then the right side is what it took to renovate the building. And so you can see that incredible savings. Dodging the cat. So hang on there. I'll turn it back to you, Jean.
All right, I'll just touch briefly. This chart here, what I'll explain on the right side is a list of materials and their impact, because on our projects, we are focusing on embodied carbon, especially at the interiors and tenant improvement scale. And so obviously it's important to make headway in the operational side of things, but embodied carbon is something that we're really bringing to the forefront of our conversations. And so what you can see in yellow is the impact of a material over the lifetime, and orange is an initial emissions at procurement. And so things at the very top are the structural materials, which obviously carry a heavy load of emissions. But it's a real eye chart, I realize, but some of the longest yellow charts there are things like furniture and carpet. And so when you think about how tenant spaces are often redone every 5 to 7 years, and a lot of times that includes pitch and everything, including the furniture, you start to realize how important it is to focus, like Jeff said, on a reuse, reduce, reuse, recycle. We have a few other words we use in there as well: reuse, reduce, replace, or optimize. But to focus on that, those key features, because the items that are a heavy load that are structural, at least they will probably be there for a long time. We hope our buildings will be up for a long time. But knowing that the tenant spaces may turn over, and we may not have control over whether things get reused, we are focusing on minimizing our carbon footprint with our material selections in that regard. And this is an example very similar to how the Alliance Center operates. We like to use our Gensler offices also as sort of living laboratories. And so Minneapolis had the opportunity to redesign their office recently. And this is an image. And some of the things that they focused on, similar to what we would incorporate in any project we work on, are low VOC materials, low flow fixtures, utilizing locally built and sourced furniture. We have an internal initiative where we message across offices when we have salvaged furniture that we can help get to other projects. So that's one way we're really trying to dig in on the furniture aspect of things. And then as well as incorporating abundant air from operable windows and natural daylight. And then last, which I feel like really ties into what we were speaking about, is they have a well dashboard that displays real-time statistics on the office environment. And then in the bottom right-hand corner, I'll just say quickly, we partnered with Mohawk Group that makes flooring, and designed a carbon neutral carpet tile that is also socially responsible and net positive to people and the environment. And so it's really encouraging to see industries like carpet, because they have such a ability to make an impact, are pushing the boundaries, and there are many carbon neutral and even carbon negative options out there to specify on projects. So very exciting.
So the industry is also seeing innovative and creative design revolving around heavy timber, mass timber, or other wood products as a way to minimize embodied carbon emissions. Materials vary in their impact. So cement used to make concrete accounts for nearly 10% of all emissions worldwide. Wood, however, has a relatively low embodied energy, as much as 5 times less than steel. To measure the carbon impact of various materials, we look at what's known as products' global warming potential. So the global warming potential is a standardized way to measure the greenhouse gas emissions associated with a product from material extraction through the end of life disposal or recycling. The higher the global warming potential intensity, the more important it may be to seek low carbon variations and alternates. And so this is an example of a mass timber building that we worked on. in Texas. So we are taking the plunge to meet aggressive net zero goals by 2030. All of us need to be a part of this major transformation. We'll be designing and engineering net zero buildings. People like the Alliance Center will be owning and operating net zero buildings. We'll be living and working in net zero buildings. So remember, planet wellness equals people wellness. And thank you. And thanks for the Alliance Center for having us today.
Yes, thank you.
Jeff and Teen, I'll field any questions in here. Danny already put something in the chat about questions from the audience virtually. Not seeing anything now. Nigel.
With the height of all of these office buildings and restaurants that are being built now, is that not also using a lot of time? We're just using a lot of space and don't need to use it.
Yeah, so for those that are virtually, Nigel's question was related to the volume in a space. What is the height of a room? How does that impact the additional heating load, additional cooling loads within those spaces? On the design side, Jeff or Teen, do you have any immediate responses on your end?
Yes, I mean, from an architectural point of view, a typical office building has a floor to floor of about 14 feet. That would give about, I mean, with or without the ceiling, it would give a approximate ceiling height of 10 feet in the space. That would be kind of the average datum within there, but obviously the volume of space would go up to the bottom of the floor deck or around the equipment that's living in the ceiling. But that's the kind of typical floor to floor of an office space.
We may also have a response from Branch Pattern.
Yeah, I think volume is really interesting.
Danny, you want to come up here so people can see you?
That's official. I was just trying to chime in. Volume is really interesting, I think, because it could impact heating and cooling loads, but from a viral standpoint or like a pollutant standpoint, it can actually help make spaces a little bit cleaner for us. So by adding volume to a space, you can dilute the air more, which is kind of an interesting like pro and con. The other thing we're doing a lot more is heating and cooling spaces at the floor, especially in schools where kids are closer to the floor. So we're not actually heating and cooling this space, we're heating and cooling where we are as humans, and pulling air out at the ceiling while the hot air is rising. So there's some more creative things you can do. So rather than thinking of heating and cooling all the air in a space, just where humans are existing. Mm-hmm.
Stuart also chimed in online. The office plate density is going to go up or down, return to private offices.
We are not seeing a return to private offices, mostly I'd say because the focus is on flexibility right now, and there are ways of avoiding traditional construction to make private offices through potential furniture solutions. But what we're really seeing is a lot of modularity and a focus on designing spaces that can accommodate a percentage of your workload and then flex to accommodate a higher, more dense floor plate, or then retract back down to, say, like a time we're in right now when you might only have a percentage of your workforce coming in.
Thank you, team. Stuart, did you have a follow-up?
No, I just, thank you. Yeah, it's a trend I'm curious about, and I know you guys have the pulse, talking to so many clients about how they plan to solve their problem. I was hopeful we might see more private spaces are smaller acoustic and, air zones just from a safety perspective, and indoor environmental quality. But there is a great allure to being back together in that experience of a shared office. So
Yep.
I appreciate that also.
Yeah,
There will-
sorry, Gene. I think from a building planning point of view, like how we're designing the major mechanical systems is also changing a little bit. So we'll see probably more floor by floor systems versus, the traditional RTU up on the top of the building, pushing all the air down and recirculating all the air within the whole building. We kind of have to move this way from an efficiency standpoint as well as kind of a health and wellness standpoint.
And I was just going to add that the functions that will happen in the office will be different going forward, in that you might stay home if you need kind of a private office day is what we're experiencing. But that you also might come into the office and need to inevitably be on a virtual call, just like we've all been doing virtual calls. So I do see that there will continue to be, which we've designed a lot of, the idea of like huddle rooms or phone rooms. So not necessarily private office, but a fully enclosed private space that you could step away into.
Okay. I am not seeing any other questions online. I have one from Mike here in the room.
I just wanted to say that's a really beautiful portfolio, and I really like Jeff's use of the bubble chart.
Mike likes the portfolio and the use of the bubble chart, and we all like the kitty here in the room.
Very popular.
Every meeting I'm in, he's with me.
So we didn't have that luxury in this room. With that, I'll kind of wrap things up. I'm thrilled that we were able to get a number of people here in person. Many more even online. There were probably upwards of 40 or 50 individuals kind of listening in person and virtually. So excited that there was quite a wide variety of folks. I think we're trying to do our very best here at the Alliance Center to impact people, operations, and technology to see what we can do to make our space better and educate others. So hopefully we can continue that path forward and work with the people that are in the room and in the virtual room and make a difference. So thank you all for coming.